Hello everyone. If you follow my channel, you probably know about AI. We have covered different topics like RAG applications, multi-agent apps, MCP and more. If you haven't watched those videos, I suggest you check them out first and then come back here. Today I want to talk about agent orchestration. But before we jump into the code, let's answer some important questions. What is an AI agent? An AI agent is a program that can understand situations, make decisions, and take actions on its own. Unlike regular software that just follows commands, an agent can figure out what to do next and use different tools to get the job done without constant human help. What is an AI agent orchestration? AI agent orchestration is just like a manager that coordinates multiple AI agents. It decides which agents should do what task, make sure they share information properly, and keeps them working together smoothly without getting in each other's way. Why multi-agent orchestration? Instead of one AI trying to do everything, you can have multiple specialized AIs that are each good at one thing. This is better because each AI is an expert at its job. You can add more AIs easily. If one breaks, the others keep working. And fixing or improving one AI doesn't affect the others. Let's see how many orchestration patterns are available. As you can see in the picture, we have sequential, concurrent, handoff, group chat, Magentic, and workflow process. In this video, I will cover first 5 items. Let's start with sequential. It passes the result from one agent to the next in a defined order. And about use cases, I can say it's obviously works on step-by-step workflows, pipelines, and multi-stage processing. But to understand better, we need a scenario, and we will implement it in our code. For this pattern, sequential, I have a recipe pipeline. Consider you have a user input about, for example, I want to have a dinner with chicken, and then I have 3 agents for this purpose. Agent 1 is ingredient analyzer, a nutritionist, knows about ingredients and quantities. So I ask this input and user question from this agent, and I get the output and pass it to the next agent as an input. And the second one is instruction writer, a chef. It knows about step-by-step cooking instructions. When I got the result, I pass it to the next agent. This is exactly the meaning of sequential pattern. And the last one is a recipe formatter, is an editor, and shows me a final recipe in a good format, really understandable. It's time to dive into the code. For sequential and the recipe pipeline, let's see how we can tackle it in C# with Semantic Kernel library. First, I want to show you need 4 different packages, all related to Semantic Kernel library. If you don't know about it, I have some videos about this in the channel, so please watch them first. You need Semantic Kernel itself. Because we are dealing with the agents, we need agents core, agents orchestration for this specific part of the video, sequential, and we need to run this agent, so we need a runtime in process package. So please install them first. Let's start with the code. In here, for working with Semantic Kernel library, we have to create a kernel And then we need to pass API key and model. I use OpenAI chat completion for this purpose. And I need to create chat completion agent. This is related to the package of Agent Core. This part was inside the Semantic kernel library, and this part is related to Agent Core. So the first agent, as I showed you in the PowerPoint slide, is ingredient analyzer. You need description. Be careful, at this moment libraries are in preview, and I had problem of timeout issue when I didn't define description. So be careful. Name, description, instruction, kernel, and arguments can help you to achieve the result. In description, I want to mention this is an agent for detailed ingredient list and something else about nutritional information and dietary considerations. And then you have instructions. What should this agent does? For example, this is nutritionist expert, and you need to have idea about required ingredient highlights. If I want to have something related to the vegan or gluten-free and etc. Let's consider this one. This is agent number 1. You need to pass the kernel instance you created. And if you need to change some settings about OpenAI, you can tackle it here. For example, I just changed the temperature. Agent number 2 is instruction writer. It's a chef, and it's related to a step-by-step cooking. And in here, I just mentioned I need a clear cooking instructions. Based on your needs, you can change it and define rules for AI, kernel and arguments. And the last one is a recipe formatter, is an agent I want to polish the things and create a professional recipe card with all tips and tricks. So description and instruction, kernel and arguments are here. This is the main part of orchestration package. For this specific sample, I want to have sequential orchestration. So you have to create it, an instance for this type, and pass your members in order: ingredient, instruction, and recipe formatter. You can also define a callback to know which one called, what was the content, when finished, and a lot of things like this. You need to run these agents, so we have to create in process runtime. If you remember, we had a specific package for this. You need to start those agents and pass your user input. For example, for this one, I asked for create a healthy weeknight dinner recipe with chicken and vegetables. And from orchestration variable, I need to invoke and pass the user input and runtime. And final recipe will available when I use the result and get value async. And based on your task, how much is complex or not, you can change this timeout here. In the end, you need to call run until idle async and stop async to dispose all of the agents. Let me run this code and see how it works. As you can see, sequential orchestration, and this is my input and processing through 3 agents sequentially. First, ingredient analyzer called. This is the content for that one. It's about required ingredients, the chicken breasts, vegetables, nutritional highlights, dietary consideration. And then I have an instruction writer. It's a chef. And as you can see, it's preparation time, cook time, total time, step-by-step instructions here. For the last one is a formatter, and format will help me to see everything in a good shape. And finally, when those agents work together sequentially, you will see a final recipe. This is a lemon herb chicken with roasted vegetables. Ingredients are here, instructions are here, helpful tips, serving suggestions, and more. So as you can see, for our scenario, sequential orchestration works very well. Let's talk about concurrent. It broadcasts a task to all agents, collect result independently. For use cases, we can think about parallel analysis, independent subtask, and ensemble decision making. I have a scenario for this specific pattern. Travel destination. Consider I want to go to Vienna in Austria, and I need to know some information about this travel. So I have a user input, my destination, and then I have 4 different agents. One agent is budget expert, knows about daily costs. Second one is a culture expert. It helps me to know about must-see cultural sites. Agent 3 is adventure expert. It shares outdoor activities and adventure things. Last one, agent 4, is food expert. It's about must-try local dishes. So I can ask for all of them simultaneously to help me to know more about Vienna. In this pattern, we have a combined version as an output. Then we can decide about should I go there or not. Let's dive into the code. As you can see, same as sequential, we created the kernel. Our destination is Vienna in Austria. And now I have a budget expert. Same as before, you need name, description, and instruction. So I mentioned you are a travel budget expert and you need to analyze the destination from a cost perspective. The second one is a culture expert. I just mentioned I want to know about must-see cultural attractions and experiences. Number 3 is adventure expert. I want to know about outdoor activities and adventures, best hiking, water sports, or extreme activities. And the last one, food expert, is about must-try local dishes. So same as before, you just need to define chat completion agent and pass the name, description, instruction, kernel you created, and arguments if you want. But in this sample, I want to do something more. A structure output for the final result. I want to have a class, and then for result of each agent, I want to get different lists. Budget insights, cultural highlights, adventure activities, and food experiences. These are different answers from agents, and I will have them in a list of a string. So I created this class, and I need to first get iChat completion service from the kernel, and then I need a variable from a structured output transform and pass my class as a generic type. Then I knew this one and pass the chat completion service. The second argument is execution setting, and for response format, I need to pass my customized type. As I explained, this example needs concurrent orchestration. So you need to define a string and travel analysis for this type and pass budget expert, culture expert, adventure expert, and food expert for the arguments. For the result transform, I need output transform, this variable I created here, and call the transform async. And same as before, to know which one is called and what was the output or when finished, I can have response callback. I have the message here. You have to run the agents, start async. You had orchestration, you need to invoke and pass your input. I ask analyze Vienna, Austria as a travel destination. Finally, I pass runtime and get value async with, for example, for this example, 90 seconds timeout should return the final result. Let me run the example. In the console, you can see those agents called simultaneously, and I got the result. In this variable, I have 4 information for text for each properties. Let's check the adventure activities. For example, for this one, it suggested Vienna woods offer hiking and mountain biking. For the budget, it mentioned staying in a hostel or shared apartment can save on accommodation costs. For cultural highlights, mentioned the Vienna State Opera is essential for experiencing world-class music performances. And for food, I can see Vienna Schnitzel is part of the answer. It's really great. Let's continue our journey with Handoff. It dynamically passes control between agents based on context or rules. When we should use it? For dynamic workflows, escalation, fallback, or expert handoff scenarios. To understand it better, I have a scenario for you. Customer support. Consider your customer has an issue. How this orchestration works. Customer asks the question, and then your first agent, front desk, analyzes this issue and understand it at the first place. Then deliver it to the expert agent, another agent. For example, if it's about authentication failure, who should answer it? Tech support or billing? Definitely tech support. So front desk as an agent understand the issue and pass it to tech support for better, valid, and proper answer. And if it's about payment, I'm totally sure the front desk agent can route it to billing support. But if none of them are able to answer, it will back to front desk, the first agent, kind of a coordinator, and it will ask for more information or the other details. But most of the time, if you have different agents and experts at different topics, the issue will resolve. Let's see how we can define handoff in the code. Exactly same as before, you have to define your agents. It's very simple and straightforward. Chat completion agent, front desk, name, description, and instruction. In here, I mentioned you are a friendly front desk support agent, and then I explained to front desk agent what kind of issues you can tackle. So for example, you can tackle technical support, software, hardware problems, or billing support, payment invoice issues. And you should transfer them to appropriate specialists. It's very important. And then I defined tech support, agent who handles technical issues, and also billing support, agent who handles billing and payment issues. For the handoff orchestration, we have something more. We should somehow define our workflow. So you need to create an object with handoff orchestration, and then you should say start with front desk. This is kind of a coordinator. And then front desk have different targets. Tech support, billing support. And tech support also can have front desk as a target. Transfer back if issue is not technical. And also the other one. For billing support, we can also define front desk target. for when transfer back if issue is not billing related. Finally, you need to pass members of this orchestration: front desk, tech support, billing support. Same as before, you can have response callback to know about author names, content, and when the agent completed the task. In process runtime to start agents. And now my customer issue. I'm getting an authentication failed error every time I try to log in into the application. This is the first issue, and I want to show you how front desk can route it to the technical agent. As always, you have to invoke and get value async. Let me run the application. You can see this is a handoff. This is my issue, and let's see the routing way. Front desk, it sounds like you are experiencing a technical issue. So route it to technical support, and technical support had an answer, and then issue resolved. This is the final answer. It mentioned for authentication failed error, you should verify credentials, clear cache and cookies, use a different browser or device, check internet connection, firewall or antivirus, account lockout, and software updates. And I guess it's a very good type of general answer. Now let me change the issue to something else more related to billing. Let me run the sample again. For this new issue, I would like to downgrade my premium subscription to the basic plan. So it's about the subscription and downgrade and refunding. So let's see what will happen. The front desk mentioned to clarify your refund concern, I will connect you with our billing support team. So understood the problem really well and routed to the appropriate agent. And in here, you can see the answer from billing support agent. And under issue resolved, it mentioned some notes you should consider. The policy regarding refunds varies by company. Typically, companies may offer a prorated refund for the remaining days left. And I guess also this one is a good general answer, but definitely you can have your custom data, train the AI, and get the best result from your agents. It's time to talk about group chat. All agents participate in a group conversation coordinated by a group manager. Typical use cases, we can say it's very useful for brainstorming, collaborative problem solving, and consensus building. I have an example for you. Creative story development. In this orchestration, you consider I want to have a story, any kind of a story, just a title, a project brief. And then I have a round-robin manager. This manager cycles agents sequentially until max round or termination condition is met. So it means we put the topic inside the group. This group contains different agents, expert in different topics. Then the manager gives them time to chat together and share the ideas. Agent knows about two things: maximum round, how many times you have opportunity to share your idea. I'm talking about agents. Or we need to define a termination condition when we should finalize a discussion, when I can approve the output. I will show you how. But it means a manager is top of the group, and I have 3 agents inside this discussion. A storyteller, which is good in story ideas and plot. A character designer knows about the character details and depths. An editor, it shared the feedbacks or tell me the output is acceptable or not. This is the exact way we can terminate this discussion. So when editor says approved, the manager understands, okay, it's done. We got a great result from this group chat. Let me show you how group chat orchestration works inside the code. You need a kernel. I defined a storyteller agent. As I said, it knows about the story concepts, plot twists, and narrative arcs. The next agent is character designer. It knows about characters, the depths, background, personalities, motivations. An editor is a kind of a finalizer. Tell me this story and characters are good or not. Should be better, continue the discussion, or just done, finalize it. To this purpose, it's very important we have a kind of keyword to finish this discussion. So I mentioned, hey, editor, hey, agent, when you approved, when you said exactly approved keyword, finalize it. That's the end. So then manager understand, okay, we got the output. Let's close this discussion. So we need to define a manager. This is very important. I said we have a round robin manager, but we should define when it will terminate and what kind of output is acceptable for me. So I designed a creative team manager. Before check it together, I want to tell you this creative team manager has 3 arguments. The name of a storyteller, the name of character designer, and the name of editor. And maximum invocation count is a maximum conversation round. After 10 rounds or after 10 turns, discussion will over. Let's take a look at the creative team manager. In here, we need to inherit from round robin group manager is available in Semantic kernel. As I said, names of agents are inside the constructor. And we need to override should terminate functionality, this method. In here, first you need to call should terminate to check if maximum invocation count has been reached or not. If not, you need to check the value. Check the last history. Check the editor name because we said editor is the last agent and should consider the final result is approved or not. So I checked author name as editor name or not. If yes, also check the keyword approved is there inside the output or not. If yes, return the group chat manager result as a true with the reason editor approved the creative concept. And you can terminate this discussion, this group chat. Also, we need to know which result after all of these discussions is acceptable for us, for the application. So you have to override filter results. Let me show you an example. As a storyteller, I ask for a robot finds love. This is the topic of the story. Character designer inside the discussion says something. A storyteller based on this discussion have something new. And then editor comes and says needs more emotion. A storyteller update it. Character designer change it. And then you have a final result from a storyteller. An editor comes here and approve it. So between these rounds turns, I should find my output acceptable result. So you need to override this method and looking for the history in a reverse mode. So last one goes on top, and I want to know about a storyteller because this is about the story. This is about what this specific agent got at last time. Then I can fetch the content. If there is a content, I return it as a result, and then I can say, hey, group chat manager result, I have a very good content. And reason is final approved story concept. So with this specific class, you can handle the condition of termination and also the result you are looking for. For example, if for you is a character designer is the thing, you can change it in the history. You can go for that specific author name and just fetch it. Let's back to the code. After using creative team manager, I can create group chat orchestration. I can pass the manager the first argument. Then I have the members, a storyteller, character designer, and editor. Same as always, response callback can help you to know who speaks. With the runtime, start the agents, and you can define your project. For example, in here, I mentioned create a short story concept about a time traveler who can only go backward. I invoked the project and runtime and all agents and time to get the value. Let me run this example. So you see the project brief, team members discussing in round robin. So you can see a storyteller speaks, character designer speaks, and editor approved. So it was a short discussion. So the final result and final approved concept is here. We have a title, as you can see, a concept, the plot, it's about Jonah, this is the character, and there is a twist for this story, and finally a narrative arc. I guess it's really amazing. So inside the group chat, a discussion between different agents, we got a final good acceptable result. Let me talk about last pattern, Magentic. Dynamically selects agents, determines execution order, and adapts the workflow based on task complexity and progress. This pattern introduced by Microsoft. And actually you just define your agents and nothing else. If you believe the AI is smart enough to tackle the tasks, you can give the control to AI. This pattern is about everything happens dynamically, smartly behind the scene with AI itself. You don't need to do anything special. It just works. So if you want to have something smart and automatic, you can go with this way, this Magentic pattern. But if you think you need more control, you need to have a step-by-step plan, it's better you consider the other patterns. As I said, for complex and generalist multi-agent collaboration, this pattern is really good. So I need a scenario. Consider I want to create a content, but in this pattern, I have an intelligent manager who decides which agents to use and when. Who do this? Microsoft library behind the scene. So I have a kind of request. I pass it to the manager, intelligent manager, not like group chat or round robin manager. You control it. So this dynamic agent selection will happen, and manager chooses workflow you need based on the agent descriptions and instructions. So for content creation, as you can see, I have an agent researcher for gathering facts and data. If needed, it will go for a strategist, plans content structure. If needed, it will go for writer, creates content. Again, if needed, editor will call for refines and polishes. And finally, if needed, SEO optimizer does the job for web optimization and keywords and a lot of things like this. But again, I want to emphasize, manager can skip, reorder, or revisit agents as needed. Finally, you will get what you want. Let me show you the code for Magentic orchestration pattern. First, I want to mention for this specific pattern, you need another package, Agents Magentic. When you add this one, you can start create your kernel and define your agents. Researcher, as I explained to you, a strategist, writer, it's a creative writer, editor, it reviews and refines content, SEO optimizer for optimizing content for search engines and readability. And in instruction of each one, I have some information, how you should deal with the content, what I need from you, and a lot of things. Same as always, you need to pass the kernel and arguments. You just define your agents and instructions you need. I need to find iChat completion service from the kernel, and then I need a standard Magentic manager, the type. I create an instance and pass this chat service with the setting you want. And same as the group chat, you have maximum invocation count. This time it's 15. When you did this, you can create Magentic orchestration. You define your manager, the instance you created here, and then you need to pass the members, researcher, strategist, and the others. Response callback, exactly same as before, to know which one is calling, which one is completed. In process runtime helps us to start the agents. And now in the user input, I asked write a short, engaging introduction paragraph for a tech startup's homepage. The company builds AI tools for small businesses. So let's see how it works when we call invoke async and get value async. Let me run the application. So my request is here. These are the agents, and the manager will coordinate these 5 specialized agents dynamically. As you can see, the manager first called a strategist, and a strategist has some output, then agent writer, then agent editor, SEO optimizer, and based on this automatic smart manager, we have final results. Welcome to Company Name, your partner in AI-powered business transformation. Our innovative AI tools for small businesses are designed to revolutionize your operations, turning everyday tasks into streamlined success. I have also some meta description suggestions, and I guess it's a good answer for what I asked. I think now you have good understanding about 5 famous useful orchestration patterns, and you can use them based on your use cases and what you need for real-world products. I hope you enjoyed this video. Don't forget to like and subscribe. Take care and see you next time.